Okay, hello there everybody. So I'm gonna be showing how to use NumPy and Python and how to get ready for like machine learning projects, deep learning projects. So I just created a new VS Code window. I have some editors open, but I'll just show you like creating a notebook. Let's say main.ipynb. That's how you create a new notebook. So I'll show you how to do like some basic programming in the beginning. And I'll be teaching like how to go to machine learning and deep learning, like more harder projects. And you have to understand how the neural network works and like more deeper dives. And I'll talk about that. So today I'll just be talking about like NumPy and just Python in general, so we can get ready for those. I'll be talking about those down the road, but let's see. So introduction to Python, we already know how to print probably from, if you did other languages, it's a little bit easier. You just have to use print, and then you have to make sure you have the strings around what you want to print, and you get it. That's like very basic. I assume you already know that. But I think like some harder things are like making functions like this. You return something from the function. So if you have this, like f5, it will give you 30. So this is an example of something that's a little more higher level. So let's see. You can practice like making functions like this, or we can do something like this, where we have more variables. We can take like x squared plus y squared, and now you can just pass in like 2, you'll get, oh yeah, I didn't say return. So you gotta make sure you always have a return statement. So that's one way to make a function. But we can also make a function using lambda, the lambda iterator, or whatever it is. It's another way to make a function, basically almost the same. And now you can take into inputs like this, make the same function like that. And now if you have f of 2 again, you can get the same output. But this is just some example using lambda and using the def. I find both of them useful, but this one kind of is confusing when it's not like this. Usually maybe you're used to seeing it like this, but you have a return right here. Usually you see it like that, but I have it in one line, so it looks similar to the lambda one. So that's just an example, but let me show you how to use NumPy now. This is what we really need to start. So import NumPy as np. So now that we imported NumPy, I'll show you how to make like an array, an example. So if you have like f equals to NumPy dot random array, random.rand. This is an example like a random array. You can create a 1x3. Oh yeah, I forgot to print it out. So yeah, 1x3. We can do 3x3 like this. It's like a matrix, just the array though. They're calling it an array. That's the data type. So we can also make another one that we can define this time using numpy.array. We can just define it like this. We can have 1, 2, 3 in there. We can have even more. We can have this, like that's like a 1x2. So let's see, we can have 3, 6, 1. That's a G, and let's go and print it out. So that's an example. This is like very basic things. But now we can create something else that's very interesting. Like we can create a variable like x equals to numpy.linspace, linspace. So this is like a lot of values. It's gonna have a lot of values. So I can show you. So if we start at 0, go to 10, and then the spacing can be like 100. So I can show you examples. It's a little bit hard to explain, but you can see that how much values you're gonna get 100 values in here, and it's gonna all range to 10. You see, 0 to 10, and it takes you can see how big the decimal points there are after it. But that's an example. So let's see if we can define a function using it. We can use the lambda. So we can do, let's do h. So h equals to lambda. And let's say now we're taking an x. So let's do something simple like x squared. Okay, so that's x squared. Remember, this is how you write x squared. Don't do this. It's not gonna work. You have to use 2 multiplication signs. Okay, let's see. We can do h of let's do h of x, because that's what we define as a linspace. It's gonna give you all these values. It's like a transformation almost. You're just changing all the values in this array here is making like a giant array. You're changing all the values in there. And then I can show you like, there's also, you can use this for matrix multiplication. Array multiplication, they call it array multiplication right now. So I can show you example, if we create two arrays, so x equals to numpy.random array. Let's see what array we can make, like a 1 by 3. Let's do a equals, let's go make a 3 by 3. This should be, I think you can do matrix multiplication with these two. I think so, because you're doing this, you're doing 1 by 3 by 3 by 3. So it's gonna be like a vector by a matrix. So yeah, it should work. Let's try it out. X. See, you get it. So we got it out. And you can try it by hand. I think you wouldn't want to do it with decimals. But let's try like an easy example. Let's try like a very easy example. Well, let's go make the 1 by 3 matrix first, which is like a vector. You can think of it as a vector. So we're gonna have x equals to numpy.array. And then we're gonna now specify it. So we have to have one bracket outside, and inside we're gonna have the values. So we make it like this. And if you want to verify, you can check using x.shape, whatever name of the. You can even check a.shape is it's 3 by 3, and you can see x is 1 by 3. We got it correct. So you can just verify whenever you think that you don't have it correctly. And even when you get like an error, like you have, like for example, you make an array called f equals numpy.random.rand. Let's say it's 1 by 3, and then you make another one like j. Let's make it like one that you can't even multiply, like this. This is not gonna be good. But let's see. F. Don't use the multiplication operator. See, this is how you can check. So I obviously should have like written it out like this, but I'm just showing you for example. Okay, so let's go back. We have let's go make a. That's numpy.array. Now we want it to be 3 by 3, so you have to be careful with this. You can't just have it like this. You can't just have it like that. That's gonna be error. I misspelled it. So you want to make sure you always have a bracket on the outside, just like this. So let's go have it. I'm adding some zeros to make it easier. And then make sure you have it right there. You start right here. Right here. So then you can have the next one. This will make a 3 by 3. So and I can verify also using a.shape. So it's 3 by 3, we got him. Now let's go do the multiplication. And we got the multiplication. Okay, everybody, so I showed you this is how you can do it. For example, you can get this array out, or you can change it to be like a 3 by 1 vector, like it becomes a column vector instead of a row vector, I think so. Okay, let me see. If you do this, 1 and then 2, 1, oh man, okay, and then 1, and then we can do it like this. At a.x. If it's a little bit confusing, I can show you. We can print out x. So I can show you what x is. So you have 3 rows, 1 column. So 3 rows, 1 column. I can show you with x.shape. 3 rows, 1 column. 3 rows, 1 column. Remember that 3 rows, 1 column. What does that mean? That means this is a column vector. But if you have x, if you have x like this, x equals to numpy.shape. I mean, no, it's numpy.array, and we make it like this, like 1, 2, 1. Let's see the shape now is gonna be. What do you think it's gonna be? It's going to be. Now it's gonna have 1 row and 3 columns, so it'll be 1 by 3. So you see right here is 1 by 3. This one is 3 by 1. 3 3 by 1, this is 1 by 3. Remember, these are called transposes. So let's see how we can do a transpose. Let me check if it works. So, then x dot transpose, I think that should work. It made the transpose of this. It should have the transpose. Wait, let me see. Why does it not? Let me see the x dot shape. Oh, if you guys, okay, let me see. Yes. Oh yeah, we did the transpose actually. So right here it's 1 by 3. We updated x to be 1 by 3. And now we made it 3 by 1 by using transpose. We can try again. I'll show you again. It should make it 3 by 1 by 3 again now. After we do it the second time, it should be 1 by 3. So now it's 3 by 1 because we transposed it from this 1 by 3. It becomes 3 by 1 again. Now it should become 1 by 3. What happened? Okay, let's see. If you have error like this, oh yeah, so we made it. It's oh, we gotta save it. Okay, I didn't save it, so we can now print x. It will be like this. Yeah, sorry about that. So I forgot to save it. So let's go and try again. So x dot transpose again. I'll make sure I save it this time so we don't have an error. And then we can now print out the x dot shape. So before it was, it's 1 by 3. Now it will be 3 by 1. See, we got 3 by 1. Now we can print out x. 3 by 1 again. Remember in here, what it was 1 by 3. So you can see that is how you transpose it. So let's see if we try to transpose A. So let's go see A. So if we have A right now, we can see that's A. We can see A dot shape. A dot shape. 3 by 3. If we transpose it, it's gonna be 3 by 3 still. I can even show you it's gonna be 3 by 3. You can just do A dot transpose. We can just print out A. It's the exact same thing, and now we can see the shape. Because if it's 3 by 3, you can't flip anything. It's gonna be 3 by 3 anyways. So it doesn't really matter if you transpose something that has n by n or m by m, whatever you call it. So let's go get back to matrix multiplication here. So remember, we get it. This is like very prevalent in machine learning. We get like a lot of errors if the matrix multiplication doesn't work. It's called shape errors. This always comes up, and then there's also data errors and stuff. I don't know. That's more complicated. We'll get to that later. So, okay, let's stop going to the random stuff. Let's stay with what we created. So we have. So now let's go try A. Let's try A. Let's try to matrix multiply A and X. So we get 1, 9, and 3. So you can even try it on paper. Do it a long way, and you're gonna get it. Let's try A. Let's try A by X. X by A. So it's gonna have error now. Let's see why. So we can write a comment. Let's see why. So if we have X matrix multiplied by A, we're gonna have this. We're gonna have the vector. We're gonna have like. Well, we can see first because of this code is very messy. Let me delete those. It's gonna be very confusing. So before we can print X before what is going on. I mean, not before there. Let's go and just move this so we can see what's going on. So I moved it here. Okay, it's gonna have an error there now. So we can see what X is. Okay, guys, look at this. So remember this. This is a column vector right here. So this is a column vector and this is a row vector. So what does that mean? That means the column vector has only one column. A column vector only has one column. You see, it's only one column, 3 rows here, 3 rows. And a row vector has only one row, but it can have any number of columns. Remember that. That's very important in things. So remember that when we're right here, this is a column vector because it has one column. This is a row vector because it has one row. So remember that. So that's why we get some errors here. We have X as a column vector. X is a column vector first. But what is A? A is a matrix. A is a matrix, so it's not a vector really. It's not a column or anything. So what are you trying to multiply here? We're trying to matrix multiply the vector by the matrix. But we usually multiply the matrix by the vector. That's why this is gonna work. That's how we do it in linear algebra, so that's why we're having error here. So remember that, don't have any errors. And also try to understand what these mean. So that's why transposing is very important. That's what we're gonna have. And now let's go and take a break from linear algebra and start doing more function work and see like some more stuff in NumPy what they're doing. Let me show you like, let's try like a function. Let's go make a lambda function again, f lambda. Let's take in x and y. Let's go make this more complicated. So let's try to make it like very, okay, let's go try to make it very hard to understand. Remember, use numpy.cosine, not just cosine. I'm too used to doing math. So let's have x here. And let's go add in y plus y times sine, times numpy.sine of y. Okay. Let's try to have f of x. So remember that x is a linspace. So we're gonna get, so remember guys, x is a linspace. We forgot the y in there. So let's go remake the linspace so you don't get confused. So it's a linspace. Let's start at 0. Let's go to 100 this time. Let's go have like 1,000 values. NumPy.linspace. I always forget that. And then y is gonna be another NumPy.linspace. Let's go make it the same. And now let's go have x and y. Now we get an area. Of course we're gonna get an area. Remember, always get an area or then you're having an error. And now we can see, if we can plot these things, we can see what is going on. So let's see, import Matplotlib. This is always going to be used in machine learning, deep learning. Always you're going to use this to visualize. And then because of in deep learning, you have like very high dimensionality. Like the data is very high dimensional. So that's why they have dimensionality reduction, which reduces it to 3D. And then you can visualize it, but it's more complicated. We'll get into that later. So import matplotlib.pyplot as PLT. That's the convention. Let's go make sure import it. Okay. So we're always going to be using plt.plot, and we can try out x and y first. It's gonna be a linear line, and then we have. Oh yeah, but we forgot we have a multivariable function. And keep it like that for now. And then let's go make, we're gonna make a Meshgrid to have multiple variables. We're gonna get an error otherwise. Or let me check. Let's have f of x, y. This probably will have an error. Oh, it worked. But it's not three-dimensional. It looks very weird. So let's go and have, let's start with something. Let's have capital XY. Capital XY equals to NumPy.Meshgrid. And we'll take an x and y. Let's see if this worked. Okay, it works. So you can see what is going on in here. It's basically just making it fit for 3D. It's making it like, let's see what is x.shape. No, it's 1000 by 1000. It's a matrix 1000 by 1000. If you want it visually, you can see x.shape, y.shape. They're both going to be the same. So you see both are one-dimensional. Meshgrid takes these one-dimensional inputs and makes them two-dimensional. So we can see here y.shape, capital Y.shape. I'm misspelling them. Okay, now you're seeing they make it two-dimensional now. So you see it right here. So let's plot it now. X capital. We always have to make sure this domain x and y, they're the domain of the function. And then we can have, I think this is how you do it. You use those as a domain. We can check if we get an error. And we get it right here. So this is very weird looking as well, but this is 3D. You can tell this is 3D already. If you use like, I was using a graphing file, but I'll show that later. So let's first try like a contour plot. So let's see, a contour plot. Or yeah, let's try a contour plot. So let's do, I think it was contour. contour F. So we have the contour plot x, y, and f of x, y. So now we're going to see all the lines, because this is a sine and cosine. You already know they're periodic functions. They have waves. It's going to be like weird looking like this. And we also make sure we have the color bar. The color bar shows like the levels, basically. Remember that this is the top of the graph. Let's see. Sorry about that. So, going too fast. Okay, remember, this is the color bar here. It shows us the levels. You're not seeing like what we were seeing right here, like this. plt.plot. And we have x, y, p, and f of x, y. Remember this one? This one is giving us like the side view. Very weird looking. We don't want to see this because we don't understand what is going on here. So that's why we're using this instead. Or we can have something more interactive. So in the graphic file we use, we make a subplot. And then we make it three-dimensional. First we use, we just make a variable and make a subplot with a 3D projection. And then we can now plot surface. So see, we get it right here. We get this very weird looking thing. Like, we don't understand still what's going on. Let me go zoom in. We can try to zoom in. So to zoom in, we have to make this much smaller. Let's try to make it like a 1. That's gonna be very small. So it's gonna zoom in a lot. Look at it, we zoomed in so much. And you can see even here, what is this? It looks weird. But here, see, you can see now, understand what's going on. We zoomed in a lot. Let's try 10. Instead, that would be 2. We don't want to zoom in too much. Let's try to see, like, other things. See, now that looks a little bit better. So you can try to understand this. Let's go into an interactive plot. Let's go into an interactive plot. That's why I have this file, but let me go and make a new file so we can both try it ourselves. Okay. Let's go make it another one. So let's go and remember we import NumPy. This is just review. Import Matplotlib. .pyplot. PLT. So I forgot to put the lib in there. What am I doing? So import matplotlib.pyplot as PLT. Remember that we always have to have this in the beginning. These are the packages for the program. And now let's go and start. Well, yeah, let's go make the function again with lambda. I'm using lambda. All right, let's go try def this time. Def f of x, y, just to be a little bit different sometimes. So we got to return. Oh yeah, we can't do it like that. What was I doing? And then we return. Okay, let's make it the same function. I think it was cosine of x. NumPy.cosine of x plus y times sine of x. Sine of y. I think so. Let me check. Or MP. About that. So let's go make sure we have that. Because I don't want to make it a different one. Okay. Yeah, that was it. Okay, we got it. We're good. So this is the function. So let's go first make the linspace. So x equals to numpy.linspace. And let's go make it zoomed in a little bit. The same as last time. Just zoomed in this time to 10 values. We'll show 10. Okay, so we got that. Now we're gonna transform it with Meshgrid. So let's go use Meshgrid to transform it to 3-dimensional. 2-dimensional. I mean, I'm sorry, I always make that mistake. The function has one more dimension than the domain, because it's transforming that. Okay, so let's take them in. Let's take them in. And I always forget NumPy. I always remember that. Yeah, it gets annoying sometimes. So x and y. And now let's go make another variable just to make it simple, so I don't always have to write f of x, y. Let's go make the z variable that takes it in, because if it's annoying to always write it. And now we can use x, NumPy. We gotta make a subplot with a 3D projection. So this is a 3D projection. and we can use it to plot the surface. Okay. Remember, always it's kind of hard to keep up with how the program is. Like you always have to write very fast. Try to like understand what's going on. And we have Z instead now. Okay. This should work. Let's see. Subplot. Why did I put... Yeah, I accidentally put NumPy instead of PLT. I'm too used to that. Okay. Okay, and remember, I forgot to put plot.show. So we gotta make sure we show the plot. After all the errors, we finally got it. And this is interactive. It looks... See, this is what we were doing. This is actually the top. You can see. Let's go make it full screen. You can see. Look at this. This is what we were looking at with the contour plot. And then we're going at the side for the other plot. See? It looks almost two-dimensional. You can actually exactly look at that. This is very interesting. You can see when we were right here. Oh, this is just the 3D plot. But when we're right here, compared to this, they're the same. These are the same. Just different colors, just weird colors. And then right here is the top of it. It's not really the same because we have different color scheme. But this is what they are. This is basically the 3D graph. And this is what is used in deep learning for optimization. If you like zoom in, you're gonna see like these minimum points here. That's what we're trying to get. Like we're trying to go to those minimum points for the loss function. Those are like the more complicated things to talk about, but you can see this. Very interesting. Anyway, let's go and try to zoom out a bit. Let's try to zoom out, and I'll show you that like very messy looking. Let's go make it 100 again. I'm gonna close this first. So now we're gonna see the very messy version right here. Look at how that looks. You see the top is like a lot of squares at the top. You can see it looks weird, but it's because of its sinusoidal. And see, we can see this. And remember, we were actually looking at this with Matplotlib. We were plotting it, and it looked like this. So you can see how it is in the side and everything. It's like very hard to understand what's going on. That's why we zoom in. And let's go and zoom in like a lot. Let's go make it 1 again. So we're gonna see like it's gonna be like a surface. So now it's gonna be a surface. You can see how it changes. See, this is just a surface now. It's just fun. It's just fun to just do this and look around and understand like what is going on. This is all the tools we're gonna use for machine learning and deep learning. It's very interesting how computers have enabled us to do such things. Okay. So we saw the main things. Next time we're gonna explore like more on how it works. We're gonna go into some more machine learning topics. We're gonna actually work with data. Like you just do x and y. We already saw this. It makes a linear line. You can make g equals to lambda of x. Taking x, and we'll just do x. Let's do x squared plus 3 times x plus 6. Regular quadratic. So it's a quadratic. We can just plot this. You can see it's gonna make a quadratic. It's very easy. This is very fun things. You can even do like, you can do things outside of machine learning, deep learning, a lot of fun things with NumPy. And obviously for machine learning or deep learning, well, really for like neural networks, that's deep learning, we're gonna be using PyTorch, it is just easier to work with for deep learning. You don't want to use NumPy because you have to define a lot of things. And PyTorch, I can show you, it's a very good library for deep learning, and it can do optimization itself. So this PyTorch, you can do optimization. And it is more widely known in the deep learning community, but NumPy is still very important for engineers, scientists, everybody, even some machine learning engineers use it just to understand, because NumPy is just to understand what is going on. That's why I made this video, for everybody to understand before we go into like more complex things. So any questions, you can leave it down in the comments. And I'll be seeing you guys later.